Hello everyone, this is Joe Childers with another episode of Cabin Fever Astronomy coming to you from the Boonshoff Museum of Discovery in Dayton, Ohio. Today's episode is Ask an Astronomer. So some of you have sent in some questions to us and we are going to answer them now, or at least 3 of them. So here we go. First off, Emery, who's in 6th grade, he says, why do solar and lunar eclipses happen? All right, here we go. We're going to start off with moon phases. So in the diagram that you can see here, the sunlight is coming from the right. And so I'm going to use o'clock positions. So 12 o'clock would be the one at the top where it looks like the moon is split in half with it right on the right. And then 1:30, 3 o'clock, 4:30, 6 o'clock, 7:30, 9 o'clock, and 10:30. So new moon happens when the moon in this diagram is at 3 o'clock. The moon is between the sun and the earth. And full moon happens when the moon is at 9 o'clock, when the earth is between the sun and the moon. At new moon, we see only the nighttime side of the sun, and it's also so close to the glare of the moon, and also it's so close to the glare of the sun in the sky that's invisible. But at full moon, we see all of the daytime side of the moon, and it's up all night long. Here's what the shadow of the Earth and the moon look like if you're viewing from above. So at new moon on the right, the moon's shadow just barely touches the Earth, whereas the Earth's shadow is long enough and large enough that the moon can spend an hour or 2 inside the Earth's shadow. So a solar eclipse happens when the moon's shadow lands on the Earth. So that means that a solar eclipse happens when the moon is between the Earth and the sun. But a lunar eclipse happens when the moon goes into the Earth's shadow. So a lunar eclipse is when the Earth is between the moon and the sun. So why don't we have eclipses every month? If the moon at full moon goes into the Earth's shadow and the moon at new moon blocks the sun. Well, it turns out that the moon's orbit is not flat compared to the line between the Earth and the sun. It's tilted by about 5 degrees. And so most full moons or new moons, the moon is passing above or below where it would need to be to make an eclipse. So we're going to start with lunar eclipses because these are easier to visualize. Here's a case where there's no lunar eclipse at all. The moon completely misses the shadow. You can also see here that there are 2 parts to the shadow. The red one in the middle that we can see fairly well is called the umbra, and any spot in the umbra has the sun completely blocked, completely inside the Earth's shadow. The outer dim shadow area is called the penumbra, and that is where, from that perspective, the Earth is partly blocking the sun. So the next type of lunar eclipse is a penumbral lunar eclipse, where part of the moon goes into that outer shadow, the penumbra, and part of it stays outside the shadow completely. These are usually too subtle to be seen with your naked eye. Next is a partial lunar eclipse, where some of the moon goes into the umbra and some of it stays out in the penumbra. Usually, because of the contrast in brightness, the part in the umbra looks quite dark, darker than you are seeing here. And then lastly, in a total lunar eclipse, the moon passes entirely into the umbra. The red color comes from light being bent around the Earth by the Earth's atmosphere acting like a lens. And it is the red wavelengths, the longer wavelengths of light, that are bent more easily than the blue ones. And so that is why the moon looks red in the Earth's shadow, because the Earth's shadow is not completely dark. Next, solar eclipses. Here is a partial solar eclipse. The moon is partially covering the sun. Now, you mustn't ever look at the sun, whether it's an eclipse or not, without taking the steps to properly protect your eyes. But those are easily found online, and that's usually eclipse glasses or using special filters. So for a partial solar eclipse, not all of the sun is covered. And there's no such thing as a penumbral solar eclipse, because if the moon misses the sun, we don't see anything. Next is an annular solar eclipse. The moon is just quite the right distance to completely cover the sun. But because the moon is sometimes closer to the Earth and sometimes farther away from the Earth, you've probably heard of the supermoon, when the moon is particularly close to the Earth. When it's far away from the Earth, it isn't large enough to completely cover the sun. So this looks pretty, but you still need your eye protection for this one. Lastly is the famous total solar eclipse. So the moon completely covers up the part that is too bright that can hurt our eyes, the photosphere. And so we see the corona, which is the outer atmosphere of the sun. I have never seen one. I'm told that no photograph can do justice to what it looks like. But fortunately, we will have a chance fairly soon. In April 8th of 2024, there will be another total solar eclipse crossing the United States. And so we can see that this path does cross Ohio. And so since we're an Ohio museum, we'll give a close-up of that state. The center line goes south of Lima, north of Cleveland. That would be the green line. Cincinnati and Columbus just barely miss having a total solar eclipse. Dayton will have one, and places farther north, like Indian Lake, looks like a pretty good place to go to. So that is our eclipses answer. It happens because the moon blocks the sun, or the moon goes into the Earth's shadow, but not every month. Next, Kristen Shore asks, why is the moon sometimes visible in the daytime and sometimes at night? Well, let's go back to this moon phases diagram again, and we'll talk about the names of the shapes. So the crescent moon is at 1:30 and 4:30 here, and the moon is less than half lit, or more precisely, we see more of the nighttime side than we do the daytime side. Gibbous is the one which is at 7:30 and 10:30, where we see more than half of the daytime side and less than half of the nighttime side. Now let's consider the angle between the direction towards the sun and the direction towards the moon. During a crescent moon, the angle is small. So if the sun is high in the sky, and the moon being a small angle away from it, the moon is also going to be visible above the horizon. Whereas the gibbous moon has a large angle with the sun, and so a gibbous moon is only visible for a few hours in the daylight, and then it either the sun sets or the moon sets. Some of the crescent moons are so close to the sun in the sky, as in the angle between the sun and the moon is so close, and also because we're seeing such a little amount of the daytime side that they're invisible to our eyes. But the gibbous moon is always bright enough to be seen with the naked eye. But which side of the moon in the sky do we look at? The two terms for the moon's shapes are waxing and waning. Waxing means that it's getting bigger each day. These would be going from 3 o'clock new moon to 9 o'clock full moon. And so the waxing moon, we see more and more of it each day. Whereas the waning moon, between full moon and new moon, between 9 o'clock and 3 o'clock, it's getting less each day. And the way to think about this is the letters D and C. So the first quarter moon, which is at 12 o'clock here, looks like the letter D, and you can say that means daring or daredevil. But the lower half of the diagram, the waning moons, looks like a C. So you can say chicken or coward. And so the daredevil moon is getting larger each day, and the coward moon is getting skinnier each day. The waxing moon follows the sun across the sky. So that means it rises during the daytime and it sets after sunset. And the waning moon does the opposite. It's already in the sky at sunrise and it will set before sunset. So the reason that the moon is sometimes visible in the sky is because as the moon travels around the Earth in its orbit roughly once a month, sometimes the moon angle to the sun is small and it's visible in the daytime, sometimes it's large. Full moon, the sun will set at about moonrise and the moon will set at about sunrise. The moon is rising roughly 50 minutes earlier each day. Last question comes from KZ Spot. What is it like being Hubble, the Hubble Space Telescope, and slowly focusing on the far galaxies from the Earth on out? Well, I don't have the time or expertise to make a video, but I can show you many different types of objects that the Hubble Space Telescope has looked at, starting close in and going farther and farther out. So first, in our own solar system, Neptune. And we can see here that there's a storm on Neptune, and we check on Neptune frequently to see how these storms change, and that will help us understand Neptune's weather. Neptune usually has the fastest winds of any planet in our solar system. It takes light, the fastest thing in the universe, 4.2 hours to reach Neptune. Light travels about 186,000 miles in 1 second. Next is the closest star system to the Sun, Alpha Centauri, 4.367 light years away. It looks like one star in the sky. It is the third brightest of the stars in the sky, but it's actually two very close to each other. And you may have heard of Proxima Centauri, or closest Centauri. That is a third star which is in a very large and slow orbit around these two bright ones. The one on the left, Alpha Centauri A, is a little bit brighter than our Sun, and Alpha Centauri B is a little bit dimmer. Fomalhaut is a star which is seen in the evenings in the fall. It doesn't get very much above the southern horizon here in Ohio, about 25 light years away. And it is one of the few stars where we have directly taken a picture of a planet orbiting that star. So the little timeline on the right shows you how small of a distance this planet has traveled in 8 years, suggesting how long it takes for its entire orbit around the star. It also looks like the gravity of this planet is what's caused that ring that we see here in the dust around the star Fomalhaut. The black circle in the middle is a blocker that was put in the way of the star so that the star's bright light wouldn't overload Hubble's cameras. And then we put in that white dot after the fact to point out where Fomalhaut is in the system and how large it is compared to that ring. The Butterfly Nebula, which is now 3,392 light years away, so almost, let's say it's roughly 900 times farther away than the Alpha Centauri system, is what's called a planetary nebula. A low-mass star, so up to anywhere from 5 to 8 times the mass of the Sun. At the end of its lifespan, after it has become a red giant, the outer atmosphere of the star is sent away out into nearby space, and a white dwarf star is left in the middle, which was the core of the original star. The shape here of the Butterfly Nebula is caused by the magnetic field of the star. And so some of the planetary nebulas will look like rings, and that's because we're looking straight into the lobe. Whereas here, looking from the side, it looks like a butterfly or a bow tie. The reason these are called planetary nebulas has nothing to do with planets, but rather, very early on in using telescopes with astronomy, the telescopes just weren't that good. And these nebulas looked like tiny little disks, which is also what planets looked like. They figured out that they were much farther away than planets, but they still called them planetary nebulas because of what they looked like. Now we know that they're very different because we have better telescopes. Trifid here, the little stars in the middle are brand new. They have just recently started their nuclear fusion and are spreading away the cloud that they came from. This open cluster has many, many more stars, and they have pushed away most or all of that nebula that they came from. But it hasn't been long enough for them to disperse and go their very different ways because of their varying velocities. So the Pleiades star cluster, which you can see with your naked eye, even in the city with all the light pollution, is another example of an open cluster. And even the 5 middle stars of the Big Dipper are a single open cluster, or part of a larger open cluster actually, all moving in the same direction through space. This is about 20,000 light years away. Globular clusters are the other kind of star cluster, whereas an open cluster will have roughly 100 stars. A globular star cluster has hundreds of thousands or even a few million stars. They orbit around the Milky Way. They're kind of at the edges of the visible stars in our galaxy. We don't really know where they come from. We have lots of ideas, but this is still a topic of active research because these stars are so very old. They appear not only for the globular clusters around our galaxy, but the ones that we've seen around nearby galaxies, to be as old as the galaxy itself. So these are like the very first stars that formed in the galaxy, and here they still are. And so they're still kind of mysterious, but they're very beautiful. And in binoculars, they will look like a cotton ball. And in moderate-sized backyard telescopes, the larger ones can look like a shimmering pile of sugar, is what some people call them. So the most famous of these is in the constellation of Hercules, at least for North America, and there's an even more spectacular one called Omega Centauri that's visible farther south on the Earth. Now we are going to the Large Magellanic Cloud, which is one of the dwarf galaxies which is orbiting around the Milky Way. This is not visible from Ohio either, but if you go farther south on the Earth, it's easily visible to the eye, and with its neighbor, the Small Magellanic Cloud, if you get away from city lights. This wispy cloud here is the leftover from a supernova. So unlike a planetary nebula earlier, where a red giant star gently lets its outer atmosphere escape into space, supernovas are what happen to larger stars, stars that start out with roughly 8 times the mass of the sun or more. And these do not gently let their outer atmosphere escape into space. These are the things that blow up and are quite bright. And whenever a supernova does go off, the light coming from that one explosion is typically brighter than the entire starlight of the rest of that galaxy when no supernova is happening. The Large Magellanic Cloud, that's the LMC here, is about 160,000 light years away. 11 million light years from 300 million light years to 5 billion light years. Here's another galaxy cluster. And twice as far away is yet another galaxy cluster. and the gravity of the nearby cluster is acting like a lens to brighten the far away galaxy cluster. So if you can use supercomputers to undo the twisting and the how it's being stretched out like this, then you can get a picture of a galaxy cluster that is too far away for us to see its light directly. It's too faint, but the intermediate cluster is helping us make it brighter. Einstein predicted this sort of gravitational lensing, how light can be bent by mass, by gravity, in the same way that on Earth our glasses and our eyeglasses are bending light to help our eyes see. And here then is the final picture, the farthest away that we have ever looked with Hubble, the Hubble Ultra deep field, pardon the typo there. So Hubble looked for many days in a row at the same patch of sky. And so it just collected more and more and more and more light. Every dot that you see here is not a star, except for that one in the middle with the 4 spikes. Everything else is a galaxy, having anywhere from a few tens of thousands of stars all the way up to a few trillion stars. Some of these stars, some of these galaxies are some of the very first galaxies that ever formed in our universe. And distances become a little bit more difficult to measure at these far away times because of the expansion of the universe comes into play. But these farthest galaxies that you see here are roughly 13 billion light years away. So there is our tour through the universe using Hubble Space Telescope pictures. If you have questions, go ahead and send them in to astronomy@boonshoffmuseum.org. Get those in by Wednesday next week, and we'll do another one of these on Friday. Thank you for watching the Cabin Fever Astronomy. Like us, subscribe us, and there's social media for us. We are going to be busy while you are hunkering down. We're going to be hunkering down too, but we're still going to be making content. Thank you so much for watching, and have a good and safe day.